Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Today we are looking at this question. It comes from electrochemistry. The statement reads that consider the setup below for purification of impure copper. This is the setup. You're having impure copper here. We have electrode A and B and the energy source. Then the question comes and says that what is meant by electrorefining? What is it? Okay, when you look at this term, it has two words conjoined together. Electro coming from electricity and refining meaning purification. So technically, electrorefining is the process of purification of an element, preferably a metal, using electrolysis. Then we come to this question. It says that identify the nature of electrode A. And this is the electrode we are talking about. What is its nature? To get this answer, you have to first find out what metal are we purifying. The metal is copper. So if you are purifying copper, this electrode here must be copper. If this is impure copper, then this must be pure copper. Then we come to this one. It says that identify the chemical name and the chemical formula of B. Okay, first of all, to know the answer for the chemical name and the chemical formula of B, you need to know what are you purifying here. We are purifying copper. So whatever we have here as the electrolyte must be the soluble copper salt. And there are so many. Preferably we can say chemical name is copper sulfate. Copper 2 sulfate. Okay. And what is its chemical formula? It is Cu SO4. Copper has combining power of valence 2 and sulfate has valence 2. So if they are 2, they cancel each other, and this is what we get. Then we come to this one. It says that which electrode? They say write impure copper or A is cathode. Okay, which electrode is cathode? So which electrode is cathode? How do I answer this? I will answer this in accordance to the intention of this setup. The intention is that copper is going to be migrating from the impure copper and become deposited here. We have to know that copper is moving in the solution as copper ions, copper 2+. So in other words, this is what we have. And copper ions are cations. And you have to know that cations move to cathode. So what does that mean? It means that A is cathode. Okay. And if A is cathode, then what is impure copper? Obviously, it's going to be anode. Yeah, then we come to this question. It says that the right half reaction at impure copper. Okay. So what reaction occurs at impure copper? Okay, this is what you have to know, that copper is moving from here, which is impure copper, to the other electrode A. And how do you represent that reaction? We represent it by this reaction. It was copper solid, now turning into copper 2+. And how do we complete this half equation? By putting 2 electrons here. Yeah, this one is an oxidation reaction, because what we have as impure copper is anode, and the reaction at anode is oxidation. Yeah, then we come to this question. It says that right half reaction at A. Yeah, this is the electrode A we are talking about. And what's happening at electrode A? From the intention, we know that electrode A, we are going to have copper deposited there. And so the change is from copper ions to copper solid. We can put it here. It's from copper 2+ ions to copper solid. And how do we complete this reaction? By putting 2 electrons here for balancing. Now, this kind of reaction is reduction. And we know that A is cathode. And the reaction taking place at cathode is reduction. Yeah, then we come to this question. It says that state the observable change at impure copper. Okay. Yeah, what do we observe at impure copper as this cell runs? Okay, to answer this question, you need to know the half reaction which takes place at impure copper. We know that copper solid is being converted into copper ions. So we can have that the half reaction is going to be C solid being converted into that. Now, I need to remind you that every time you have a solid undergoing oxidation to form ions, that half reaction is accompanied by reduction in size or reduction in mass. So what do you observe here? There is decrease in mass or decrease in size. Yeah, then we come to this question. It says that state the observable change at A. So this is our A. So what is being observed at A as the cell operates? So this is what we have to know, that to answer this question, you need to look at the half reaction which takes place at A. Okay, and the half reaction is from copper ions to copper solid. So we can have it here. Is copper ions changing to copper solid. And we can balance by putting the 2 electrons here. Now, I need to remind you that every time you have ions changing into a solid, that half reaction is accompanied by increase in size. So what are you going to say here? That the size of A increases. Yeah, then we come to this case. It says that state what happens to the concentration of electrolyte B. Give a reason for your answer. So this is the electrolyte we are having. It's B. And what happens to it? To answer this question, you have to look at the half reactions. And this is what we have. that at anode, we are having copper solid being oxidized to copper 2 ions plus 2 electrons. This is the reaction at anode. Okay, at cathode, what do we observe? The copper 2 ions take up 2 electrons to give you copper solid. So, this is what we have at cathode. So once you have these two reactions and you see that one is the reverse of the other, the conclusion is known. What's the conclusion? There is no effect on the concentration of the electrolyte. Yeah, that is it. And what's the reason? The reason is that the rate of oxidation at anode is equal to the rate of reduction at cathode. Yeah, then we come to this question. It says that state the energy changes which take place in the setup above. Yeah, what energy change takes place in this setup? Okay. Yeah, the energy change is electrical to chemical. How do you know that? Because having this energy source implies that this energy source is the one which drives the chemical reactions which are taking place inside here. So there's a trick here. Every time you have a battery or energy source on the setup, the change is from electrical, which is provided by the energy source, to chemical. Yeah, then we come to this question. It says that at the end of experiment, a heap of impurities, P, so this is it, is formed at the bottom of the cell. Okay? Then, what term is used to refer to the heap of impurities, P? Yes. What do we call that heap of impurities? Yeah, we call it sludge. Okay? And then the second question comes. It says that give one importance of this heap of impurities. Yeah, what's the importance of sludge? The importance is that sludge contains precious metals like gold, silver, and others. And these precious metals can be recovered from it. Yeah, that is it. It contains precious metals like gold, silver, platinum, and others. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet with me, Richard here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.